So, hello everyone, as we are seeing the chapter from MCS 014, and the chapter name is uh, Introduction to SAD. So, block 1 is Introduction to SAD. Let us see, we had completed till before check your progress. The answers of check your progress you can find below. If we will go to the end of the chapter, yes, please wait, I'm showing you. Just a minute. Yes, after summary, you will find all the answers of check your progress. Then comes the end. So let us see today what we have to learn or see. So after check your progress, I recommend you to solve them one by one. Then we will have today we will start with distributed systems. So what is a distributed systems? A distributed system in which the data process and interface component of information system are distributed to multiple locations in a computer network. Accordingly, the processing workload required to support these components is also distributed across multiple computers on the network. In this system, each processor has its own local memory. The processors communicate with one another through various communication lines, such as high buses or telephone lines. The processors in a distributed system may vary in size and function. They may include small microprocessors, workstations, mini computers, and large general purpose computer systems. The implementation of a distributed system is complicated and difficult but still is in demand. Some of the reasons are the modern businesses are already distributed, so they need distributed solutions. In general, solutions developed using a distributed systems paradigm are user friendlier. They have the following advantages: resource sharing, computation speed up, reliability, communication. The five layers of distributed system architecture are: presentation layer is the actual user interface. The inputs are received by this layer and the outputs are presented by this layer. Presentation logic layer includes processing required to establish user interface. Example: editing input data, formatting output data. Application logic layer includes all the logic and processing required to support the actual business application and rules. Example: calculations. Data manipulation layer includes all the command and logic required to store and retrieve data to and from the database. Data layer is actual stored data in the database. So here we come to the end of distributed system. There are some check your progress. You can see yourselves and can solve. And now we come to development of successful system. The success of any system depends on the approach of building it. If the development approach is right, the system will work successfully. Depicts a system development life cycle. System development life cycle (SDLC) is a standard methodology for the development of information system. It mainly consists of four phases: system analysis, system design, system construction, and implementation and system support. Every phase consists of inputs, tasks, and outputs. Traditional SDLC was strictly sequential. The developers first complete the previous phase, then start the next phase. But now concept of repository is introduced in SDLC. and it is known as fast methodology, where work is done across shared repository. It means that all the inputs and outputs of phases must be stored in the repository. At any time, developers can backtrack to previous phase, and they can also work on two phases simultaneously. Primary investigation, determination of system require, design of system, development of software, system testing, implementation, and evaluation. For making a successful system, the following principles should be followed. Both customers and developers should be involved for accuracy in the information. A problem solving approach should be adopted. The classic problem solving approach is as follows: study, understand the problem and its context. Define the requirements of a solution, identify candidate solutions, and select the best solution. Design and implement the solution, observe and evaluate the solution's impact, and refine the solution accordingly. Phases and activities should be established for consistent development of a system. Some standards should be established. These standards are documentation standards. It should be an ongoing activity during the system development lifecycle. Quality standards checks should be established at every phase for ensuring that the output of every phase meets the business and technology expectations. Automated tool standards, hardware and software platforms should be finalized for the development of information system. Automated tool standards. Prescribed technology will be used to develop and maintain information systems and to ensure consistency, completeness, and quality. Development of information system should be considered as capital investment. The developer of an information system should think about several solutions of a particular problem, and every solution should be evaluated for cost effectiveness and risk management. Cost effectiveness is defined as the result obtained by striking a balance between the cost of developing and operating an information system and the benefits derived from the system. Risk management is defined as the process of identifying, evaluating, and controlling what might go wrong in a project before it becomes a threat to the successful completion of the project or implementation of the information system. Multiple feasibility checkpoints should be built into system development methodology. At each feasibility checkpoint, all costs are considered sunk, that is not recoverable. Thus, the project should be re-evaluated at each checkpoint to determine if it remains feasible to continue investing time, effort, and resources. At each checkpoint, the developer should consider the following options: cancel the project if it is no longer feasible, re evaluate and adjust the cost and schedule if project scope is to be increased, reduce the scope if the project budget and schedule are frozen and not sufficient to cover all the project objectives. Divide and conquer approach is the way of making a complex problem easier. In this approach, the large problem system is divided into smaller problem subsystems. For development of a successful system, the system should be designed for growth and change. While the system is implemented, it enters the operations and support stage of life cycle. During this stage, the developers encounter the need for changes that range from correcting simple mistakes to redesigning the system to accommodate changing technology to making modifications to support changing user requirements. These changes direct the developers to rework formally completed phases of the life cycle. So here we come to various approaches for development of information systems. So I think mm, this is the last part, and I will, for your convenience, I will write down all the check your progresses and will give you a file in the description so you can just see there, and if you want you can download. So it will be easy for you to uh, revise or get the notes question wise, like question one and answer, question two and answer. Okay, I will send it and you can just check it. Soon I will send in the description. Okay. Various approaches for development of information system. Various approaches are available for development of information systems. They are: number one, model driven. It emphasizes the drawing of pictorial system models to document and validate both existing and or proposed systems. Ultimately, the system model becomes the blueprint of designing and constructing an improved system. Accelerated approach. A prototyping approach emphasizes the construction of model of a system, designing and building a scaled down but functional version of the desired system is known as prototyping. A prototype is a working system that is developed to test ideas and assumptions about the new system. It consists of working software that accepts user performance calculations, produces printed or display information, or perform other meaningful activities. Just joint application development. It is defined as a structured approach in which users, managers, and analysts work together for several days in a series of intensive meetings to specify or review system requirements. In this approach, requirements are identified and design details are finalized. Structured analysis and design approach. The goal of structured system analysis and design is to reduce maintenance time and effort. Modeling is the act of drawing one or more graphical representations of a system. Model driven development techniques emphasize the drawing of models to help visualize and analyze problems. Define business requirements and design information systems. The first model driven approach is structured analysis and design approach. Structured analysis is a development method for the analysis of existing manual systems or automated systems, leading to development of specifications, expected functionality or behavior. For proposed system, the objective of structured analysis approach is to organize the tasks associated with requirement determination to provide an accurate and complete understanding of a current situation. The major tasks of structured system analysis approach are: preliminary investigation, problem analysis, requirement analysis, decision analysis. It is a process centered technique that is used to model business requirements for a system. Structured analysis introduced a process modeling tool called the data flow diagram used to illustrate business process requirements with the help of DFD. The systems analyst can show the system overview. Data modeling tools such as entity relationship diagrams are used to illustrate business data requirements. With the help of ERD, the analyst can show database overview. Structured design utilizes graphic description, output of system analysis, and focuses on development of software specifications. The goal of structured design is to lead to development of programs consisting of functionally independent modules that perform relatively independently of one another. It is a specific program design technique, not a comprehensive design method. Thus, it does not specify file or database design, input or output layout, or the hardware on which the application will run. It provides specification of program modules that are functionally independent. It is a process centered technique that transforms the structured analysis model into good software design models. Structured design introduced a modeling tool called structure charts. They are used to illustrate software program structure to fulfill business requirements. Structure charts describe the interaction between independent module and the data passing between the modules. These module specifications can be passed to programmers prior to the writing of program code. In structure chart, the whole application is divided into modules, set of program instructions, and modules are designed according to some principles of design. These principles are modularity, modularity and partitioning. Each system should consist of a hierarchy of modules. Lower level modules are generally smaller in scope and size compared to higher level modules. They serve to partition processes into separate functions. Coupling. Modules should be loosely coupled. It means that modules should have little dependence on other modules in a system. Cohesion. Modules should be highly cohesive. It means that modules should carry out a single processing function. Span of control. Modules should interact with and manage the functions of a limited number of lower level modules. It means that the number of called modules should be limited in a calling module. Size of module. The number of instructions contained in a module should be limited so that module size is generally small. Shared use of functions. Functions should not be duplicated in separate modules, may be shared. It means that functions can be written in a single module and it can be invoked by any other module when needed. Prototype. A prototyping approach emphasizes the construction model of a system, designing and building a scaled down but functional version of a desired system is the process known as prototyping. A prototype is a working system that is developed to test ideas and assumptions about the new system. It consists of working software that accepts input, performs calculations, produces printed or displayed information, or performs other meaningful activities. It is the first version or uh, iteration of an information system that is an original model. Custom evaluates this model. This can be effectively done only if the data are real and the situations are live. Changes are expected as the system is used. This approach is useful when the requirements are not well defined. A prototype is usually a test model. It is an interactive process. It may begin with only new functions and be expanded to include others that are identified later. The steps of prototyping process are depicted in Figure 1.4. They are: identify the user's known information, requirements, and features needed in the system. Develop a working prototype. Revise the prototype based on feedback revised from customer. Repeat these steps as needed to achieve a satisfactory system. Actual development of a working prototype is the responsibility of a systems analyst. The difference between a prototype model and an actual information system is that a prototype will not include the error checking, input data validation, security, and processing completeness of a finished application. It will not offer user help as in the final system, but sometimes the prototype can evolve into the product to be built. The prototype can be easily developed with tools of fourth generation languages, 4GLs, and with the help of computer aided software engineering, CASE tools. Prototyping approach is a is a form of rapid application development, RAD. Joint application development. So yes, this is the last part. It is defined as a structured approach in which users, managers, and analysts work together for several days in a series of intensive meetings to specify or review system requirements. The important feature of JAD is Joint Requirements Planning, which is a process whereby a highly structured group meetings are conducted to analyze problems and define requirements. The typical participants in a JAD are listed below. JAD session leader. The JAD leader organizes and runs the JAD. This person is trained in group management and facilitation as well as system analyst. The JAD leader sets the agenda and sees that it is met. The JAD leader remains neutral on issues and does not contribute ideas or opinions but rather concentrates on keeping the group on the agenda, resolving conflicts and disagreements, and soliciting all ideas. Uses. The key uses of the system under consideration are vital participants in a JAD. They are the only ones who have a clear understanding of what it means to use the system of a daily basis. Managers. The role of a manager during JAD is to approve project objectives, establish project priorities, approve schedules and costs, and approve identified training needs and implementation plans. Sponsors. A JAD must be sponsored by someone at a relatively high level in the company, that is the person from top management. If the sponsor attends any session, it is usually at the very beginning or at the end. System analyst. Members of the system analyst team attend the JAD session, although their actual participation may be limited. Analysts are there to learn from customers and managers, but not to run or dominate the process. Scribe. The scribe takes down the notes during the JAD sessions. This is usually done on a personal computer or a laptop. Notes may be taken using a word processor. Diagrams may directly be entered into a case tool. IS staff like systems analysts, other IS staff such as programmers, database analysts, IS planners, and data center personnel may attend to learn from the discussions and possibly to contribute the ideas on the technical feasibility of proposed ideas or on technical limitations of current systems. The following are the various benefits of joint application development. Actively involves users and management in project development, reduces the amount of time required to develop a system, and incorporates prototyping as a means for confirming requirements and obtaining design approvals. So check your progress. The last check your progress is this, and let's see the summary. In this unit, all the basic concepts that are necessary to understand the system types and characteristics are given. Concepts about real and distributed systems are also discussed. Development of a successful information system depends on principles of SDLC. Different approaches are available for development of information systems. These are model driven, structure analysis, and design approach, accelerated prototype, and JAD approach. Selection of the approach is based on the end user requirements, problem identified, and infrastructure provided. So here we come to the end, and I will surely provide you with the file in the description. So thank you for listening, and till then, keep working.